Solve the inequalities x plus 4 less than equal x squared plus x less than 12. So in these questions here, this is a joint inequalities evolved of the case of quadratic. And let's see the strategy on how to solve this. First of all, we would like to separate or break these inequalities into two cases. The first case, as I highlighted in green. The second case, as I circled in red. So as a result, by doing this, originally in our solutions will be from the joint inequalities as I written here. I will break it into two cases, which is x plus 4 less than equals to x squared plus x. And the other case will be x squared plus x less than 12. And the relationship between these two will be the case of n. From a joint inequality like this, when the time we break into two cases, their relationship is the n. And in this case here, we have two cases where we call as case 1 and case 2. So in order to solve these questions, we're going to solve case 1 to find its corresponding solution. Solve case 2, find the corresponding solutions. Then the solution for each of the case, we're going to have the relationship of n, which is going to intersect the solution for each of the cases for the final answer. So therefore, without further ado, let us try to solve for the first case here, which is a quadratic inequalities. So what I will do here is that I would like to group all the terms on one side. So let us group all the terms to the right. I have 0 less than equal x squared minus 4. And this one can be rewritten as, by keeping the x term on the left, I have x squared minus 4 greater equal 0. Then by factorizations, I will have the result as follow, having two factors, x minus 2, x plus 2 greater equal 0. Reach up to here for quadratic. I will recommend we try to solve using graphical methods, and as a result by graphical methods, I have a smiling face curve graph with the intersections here equals to -2 and 2. And how I get this value here is based on taking these factors here equal to 0, I get -2. Taking the other factors here equal 0, I got 2. And next, when the time I want to decide the answer, by referring to greater equal 0, I'm looking for the parts where the graph is above the horizontal x-axis, which is this part that here I highlighted. And the corresponding x value will be, for the left hand part here, -infinity all the way until this point here, -2. The other one, from 2 until infinity. And if I write the answer in the form of interval notations, I will have it as -infinity until 2, close bracket, because I have equal sign here, union, the other part, close bracket, 2 until infinity. So this is a solution for the case number 1. Then we back to case number 2. So case number 2, we rearrange the terms, all the terms on one side. So I have x squared plus x minus 12 less than 0. Next, I go on with factorizations, where I have the result as x plus 4, x minus 3. And from here, I go for graphical method once again. I will have a smiling face curve, where smiling face curve, because I have the coefficients for my x squared here is a positive coefficients. Similarly, the other one also positive coefficient. That's why I have a smiling face curve. And then the corresponding intersections is based on the factors, where I have -4 and 3. Again, when the time I take these factors here equals 0, it gives -4. The other factor equals 0, I got +3. And now in this case here, the decision of the answer is based on less than 0, which is referred to the part of the graph which is under the horizontal axis, the x-axis. And the corresponding x value here will be from -4 until 3, but exclude -4, exclude 3 because there's no equal sign here. So as a result, if I put the answer in the form of interval notation, I will have it as open bracket -4 until 3. Both of them is open. So with the solutions I have for case 1 and case 2, these solutions, we're going to relate them with intersect because the relationship is n here, and therefore I need one more number line. I need one number line to decide the final answer, to summarize the result. So in this number line here, we're going to refer to the intersection between these two intervals. And to construct the number line, first of all, I would like to observe what is the number that I need to label on the number line, where it is based on the numbering that I can see for the solutions, where I highlighted in blue now. So continue. As a result, on the number line, if I arrange accordingly, I will have smallest -4, followed by -2, 2, 3. And this is all on x value. In fact, just now this one also on x value, the x-axis. Okay, now I put in the first case solutions. So the first case solutions, I will have -2 with a dense circle and all the way to -infinity. The other one from 2 and all the way to positive infinity. And both of these arrow here should on the same level, same height, because they come from the same sets of solutions. Then the second case, let me use another color to represent it. So I have -4 to 3. So it will be the case of empty circle on both -4 and also 3 connected with a line. And now in this case here, I'm looking for the case of intersections. I'm asking for intersections. So by observing from this diagram here, the intersections that I'm supposed to have will be the part that I highlighted in yellow now. In terms of line, it will be from -4 until 2, from 2 until 3. But the border value, -4, -2, 2 and 3, we need to consider whether do they happens to have fulfill the requirement that we want here. So in this case here, we're asking for intersect. So for -4 is not included because intersect, I must have both of them include, not either one of them. So therefore, I have -4 open brackets, -2 close because both of them consist of -2. And then there's a gap between them. So I continue with a union to connect them. Close bracket 2, 3. So therefore, this is the solutions if we want to write in interval form. Then if we want to write in set notation, it will be, we have a curly brackets, start with x, colon. Then for these first sections here, it will be represented by the inequality, -4 less than x less than equals to -2. To connect with the second parts here, we connect with the words or, followed by the inequalities, 2 less than equal x less than 3. So there goes the answer if it want to represent in set notation. By the way, usually in your final answer, you just need to represent either one of them, depends on the requirement of the question. You don't have to write it both. So that's it, the solution for these questions here.